All right, so two quick things before we start. First off, apparently for the videotaping, I should try and stay as close to the screen as possible, but I like to move a lot when I'm talking, so if it looks like I have to be, it's just because I really want to like walk around and move, but I can't. So, and I might actually have to be too, but that's just a coffee setting. Second thing, how many of you guys know about Kubernetes? Raise a hand. Okay, how many people use Kubernetes currently in production or, in some kind of environment at work? Awesome. How many people have set up Kubernetes on their own? Okay, so can we get a round of applause for all those people because they've been through some real pain in their lives. They probably cried. They probably don't have any real hair anymore like me because, setting up Kubernetes is hard. That is some hard stuff. And scaling Kubernetes clusters, it's not easy in and of itself. Especially managing worker nodes and getting them all appropriately configured, getting them to run the things that they need to run is not great. This hurts a little bit to admit, but Docker Swarm is fantastic at setting up. Docker Swarm is fantastic at setting up and only at setting up. Running applications inside Docker Swarm sucks. It's very, very difficult to manage applications inside Docker Swarm. But where they got it right was in setting up and configuring the clusters and making it easy to be able to configure them. And so we, as the Kubernetes community, are starting to learn from how the Docker Swarm guys are doing things and from some feedback from the community on how we can make that installation experience easier and how we can improve the overall experience with Kubernetes, but also how we can improve the actual technical concepts behind Kubernetes at the same time. And so coming into play with that is the Kubernetes NodeSet. So managing the nodes with Kubernetes. So first, I'm speaking here today on behalf of Lutza. Lutza is a container and cloud native company. We're based here in Hamburg, and we're a member of the CNCF, the Linux Foundation, and we're GCP partners. Who am I? I'm Jason Murray. I'm the senior infrastructure architect at Lutza, and I've worked with Kubernetes for over 3 years in production. So if you think you had pains setting up Kubernetes clusters, they say the master has failed more times than the beginner has even tried. There's a reason I have no hair. So, currently deploying Kubernetes is a pain in the ass. A lot of people deploy things using some of the existing solutions that are already there, things like Puppet, Chef, Ansible, etc. Or we use something that's already built into the cloud provider, whether that be AWS, Microsoft Azure, or Google Kubernetes Engine, which is probably historically the best experience on getting started with Kubernetes. We have some newer semantics with things like Terraform, but still, as we start using those kind of things, we're still dealing with operations to be able to scale our clusters, to be able to configure our clusters, to be able to do some things that seem like they should be pretty simple to do. I mean, in Kubernetes, I can say, here I want to have 500 of these things, and it's one command. It's very simple for me to be able to scale my application, assuming my application is scalable. But to be able to get the infrastructure to be able to scale, I need to talk to ops and go, hey, so I need a bunch more VMs. I need you guys to go ahead and configure those for me. And because we're running on AWS, I need you to do some particular things, set some particular tags on those VMs so that, they join into the cluster and they can use the appropriate resources, etc. You have to use some kind of external dependency, whether that be a Ansible, whether that be a Chef, whether that be SSH. I don't care how you're doing it. You have to do it outside of your Kubernetes cluster. There's no generic way to do it. Everybody does it differently. Even within the Kubernetes ecosystem, the KubeADM has a totally different concept of how to scale a cluster than something like Hops does, even though they both belong to the Kubernetes ecosystem. And to move your cluster onto a new platform requires a huge investment of time and a huge change in the way that you manage the semantics of your actual cluster. So we're going to take a step back and go, okay, Kubernetes manages some other kinds of resources, and it manages those very, very effectively. How can we use some similar semantics? So if you take a look at a persistent volume, it gives us a higher level abstraction than what we're familiar with an actual volume itself. It insulates us from the provider-specific implementation. I don't care for my PV whether it's sitting on GCP. I don't care whether it's sitting on Ceph. I don't care if it's a host volume. It doesn't matter. I implement a PV as an admin, and then users can come along and say, hey, I need this much, and consume that resource. Just in the same way that pods can go along and consume memory and CPU. Persistent volumes can dynamically be created with a storage class, and they have an independent lifetime of their consumers. The pods, they come and go, but persistent volumes stay the same. And they're dynamically scheduled. I mean, they aren't technically scheduled because they're not a thing that you start and stop, and dynamically managed. So what if we could do the same thing with nodes? That brings us to a kind of interesting semantic. So imagine you could do kubectl create node. If it's that simple, immediately devs are able to scale the cluster. We don't care about the nodes. They become cattle. Is there anybody here who isn't familiar with the pets versus cattle semantic? Okay. Good, you made it. If my demo fails, he's going to save me. So, and if we have a generic way, just like persistent volumes, to be able to address a node, now we don't care about what cloud provider we're sitting on top of. We don't care about, if we're sitting in our own clusters, maybe on top of VMware or something similar, or whether we're sitting on top of, Exascale or AWS or GCP, or who cares? It doesn't matter anymore, because as long as there is some kind of semantic for us to be able to leverage, you just interact with kubectl the same way you do with every other kind of resource in Kubernetes. So having that consistent interface could be pretty cool. And so that's what we thought a little while ago when we were implementing, as part of our product, Kubernetes, a whole bunch of different cloud providers to include those into our solution. And we went, hey, this is kind of dumb. We're having a really hard time doing all of these things because we're having to implement, logic around the nodes themselves. And then we're implementing logic against the specific cloud provider, and we're duplicating all of that. We need a better semantic. We need to be able to have that abstraction away from the nodes and away from the cloud provider, and have that in a clear, defined way. The issue is the way that we traditionally treat nodes. So historically, when you've needed a node, you've gone and created the node, and that node has then registered with Kubernetes and said, hey, I'm here, give me some stuff to do. But that isn't how any of the other Kubernetes resources work. Everywhere else, it's, I create a pod, and then the scheduler puts that pod somewhere. And then the kubelet picks up that pod and tells Docker to start it. It's always the other way around. So we went, okay, how can we do this with nodes? And that's where we came up with the node controller. So a node controller just watches for node resources, the same way that every other controller in Kubernetes works. We've created our own resource type using custom resource definitions, and hopefully we'll get upstreamed into Kubernetes. Everybody cross your fingers. Where we act the same way with a node resource as we act with every other kind of resource in the cluster. We provision a machine using provider-specific drivers, so AWS drivers, or GCP drivers, or bare metal drivers with Packet, something like that. The machine joins the cluster, and then the kubelet is responsible for updating the node resource. For the drivers, currently we're using the open source Docker machine implementations, and we use that driver interface, which means that it's a huge advantage for every single provider out there, because if they create a driver for Docker Swarm, they have a driver for Kubernetes. If they create a driver for Kubernetes, they have a driver for Docker Swarm. And we have that consistent interface across many, many different cloud providers. And also, conveniently for us, instead of us having to continuously recreate all of these cloud provider implementations that we were doing by hand before, now we can just go use the open source ones that are already available on Docker's GitHub. Saves me a lot of time writing code. So, oh God. Apparently my remote has decided it doesn't want to work anymore. So we have node classes. Node classes encapsulate a cloud provider. So you have a controller. Controllers act on resources. They don't do anything except, they don't create anything except for resources that are already there and updating those or acting on the resource types. So we have to have a resource. Resource in this case is a node class. So node class encapsulates the cloud provider specific implementation, details about the OS, maybe some credentials if it's required for interaction with your provider's API, the type of machine, if so required, and any provisioning details, which could be things like systemd units, SSH keys, etc. And you can also execute arbitrary commands via SSH. So if you want your machine to start up and do a cow say when it first boots, you can make it do that in part of your node class. Probably not the most professional thing, but hey, you know, we all have cat gifs in our Slacks for a reason. So then you have this concept of a node class that defines a type of node, but you don't have any nodes yet. So we want to have a group of nodes. We've defined a type of node. Now we want to have something that encapsulates a group of nodes themselves. And so we have the NodeSet. NodeSet integrates with the Node Autoscaler, and basically it's the equivalent of a deployment and pods. Think of nodes as being like pods. The NodeSet is the deployment for pods. So it defines things like the replicas, the node controller that's going to take action against this node set, and the node class. Then we have this fabulous little resource called the NodeSet controller, which does the actual interaction with the cloud provider API to create and delete the node resources, the nodes themselves. And all it does is sit there and make sure, you know, cluster nodes equals whatever the NodeSet replica count is. So now comes the fun part, the demo time. So we've already got, I don't know how I'm going to do this. I'm going to, oh, yes, saving me already. Perfect. Actually, is this critical for you guys recording? Okay, so we'll still use the microphone. All right, so I'm just going to do namespaces so that you guys can see what's running. So we have most of the regular stuff. The only thing that we have that's really going to be any different for you guys is that we're running the NodeSet controller. That's it. We've got the node problem detector. If you guys aren't familiar with that, check it out. Freaking awesome. Saves you so much headaches. But yeah, all we're running that's special in this cluster is the NodeSet controller. In the API plane, you'll notice that you don't see any of the API stuff. That's because as part of Kubernetes, which I use to spin up this cluster because it's super easy to use. It runs the control plane inside another Kubernetes cluster, which is kind of awesome in and of itself. If you haven't heard about that, come check us out because it's fantastic. And inside the API plane, we're running that node controller that I talked about earlier. So we have the NodeSet controller running inside the system, and we have a NodeSet. So we can do so we can see that I have this fantastic, cute little NodeSet called my NodeSet. So we'll go ahead and take a look at that NodeSet. Can you guys see that, by the way? Should I make that a little bigger? Big enough. So pretty simple stuff. We have most of the normal stuff, the namespace, etc. And then we have interestingly, 3 of the same things that you will see on a spec for deployment. Max search, max unavailable, and then the replicas. Then you see the NodeSet controller, which is just a string that represents which NodeSet controller is responsible for this NodeSet. That allows us to have different NodeSet controllers that implement different logic, just like you might want to be running several different ingress controllers. We give you the ability to also run the different NodeSet controllers that have different logic. And then we've defined a node class as being DigitalOcean CoreOS 4 GB nodes. So we asked for 1 replica. Right now we have 1 replica, and we're running 1 replica. But that's really boring, so let's change that. And conveniently, my boss didn't come today, which means that we're going to get crazy with this. So I want to run lots of replicas. Like, who wants a 1 node cluster, right? That's super boring. So let's go. That seems like a good number.
That's the best you would pay you.
Yeah, well, maybe. We have rules from DigitalOcean that we're not allowed to use more than 1024 cores in a data center without notifying them first. We're going to stay under that. Otherwise, I'd go like way crazy. So here I've gone and edited my thing. So nodes, and we're going to watch this. So I'll scale this, and you can take a quick look. So there's a lot of stuff that's happening right now as we're watching this. We see that we have 2 nodes currently that are in ready state, a whole bunch more nodes that are starting up in ready state. All I've done is I've said, hey, scale my replica, or not my replica set. So easy to confuse now. Scale my node set. Here, give me a bunch of nodes. I haven't had to do anything else. I haven't had to go to the cloud provider and add some nodes. I haven't even had to, as great and easy as it is here to go click add a node and add some nodes, or call our API, curl it, whatever, and say, here, add a bunch of nodes. Fantastic. But that means I have to know about Kubernetes. That means I have to know about my cloud provider. That means I have to know about Ansible. I don't want to know any of those things. I'm dumb. Like, I want to know one thing. And I want that one thing to do everything. And that's Kubernetes, right? Otherwise, I can focus on my application, and that's the important thing. I'm not here. I don't make any money by, well, most companies don't make any money by standing up Kubernetes clusters. That's all I do all day. That's my job, is going to other companies and standing up Kubernetes clusters for them. So maybe in my case, I'm kind of shooting myself in the foot. But nobody wants to go out and make Kubernetes clusters. That's not the goal at the end of the day. The goal at the end of the day is I want to have some awesome application that I'm delivering to customers. Unless you're like me or Goose, you aren't delivering a Kubernetes cluster to your customers. You're delivering some kind of app. You're delivering some kind of product. You're delivering some kind of service that's probably kind of important or probably kind of cool to your customers. You want to make this stuff go away because this is annoying. And so that's what we're trying to do here with this whole NodeSet thing. So now, fantastically, I have a gigantic cluster. My boss is going to kill me, for the record. And I've got I have no idea how many I actually have, so Oh, there we go. So we're at 21 nodes, which is fine because I already had one node provisioned in there.
Oh, the first line.
Yeah. Oh, yeah. So it's right. I'm just dumb.
Our product works fine.
Henrik did good. So, and now you can see in our dashboard's apparently super slow in updating, but you can see on our dashboard that all of these nodes are created. Now, my boss is going to murder me, so I'm going to go undo that real fast. Now, we aren't awesome yet, like deployments where you can just like roll back. Why would you even want to do that, I guess, really? But let's go back to one so that my boss doesn't get too mad at me for doing this for like several hours. This way I only have one node when I forget to delete it after the presentation. No, we never forget to do that. No, not at all. Friday we didn't have 50-something machines on DigitalOcean going, where did these come from? So yeah, let's go back to the presentation here and talk about some interesting stuff. So, I guess I don't have any more slides. That sucks. Oh yeah, I've got the hiring slide. So the important thing about Kubernetes is that it's supposed to make your life easy. I'm an ops guy. I'll admit to that. But I shouldn't be. Neither should any of you. Neither really should anybody else, unless they happen to work for some company that has infrastructure that you are running your stuff on. And if you own your own infrastructure, then yeah, you should probably have like a guy who changes hard drives and stuff like that. But you shouldn't have to care about what's underneath your application. You shouldn't have to care about what's there. That's the beauty of Docker. That's the beauty of Kubernetes. That's the beauty of all these technologies that we're starting to play around with, is that they say all of that stuff that you used to need to know goes away. And you can run, I don't know if you guys are familiar with Alex Polvey, the CEO of CoreOS, but he calls all of this Giphy. Kelsey Hightower has picked that up from him as well. Google's infrastructure for everyone else. I don't care about the infrastructure. I don't want to know about it. I just want to be able to deploy my application to it and know that it's going to run, know that it's going to scale, know that it can manage itself, and not have to pay attention to it anymore. And not have to care whether I'm using an AWS Elastic Load Balancer or application load balancer or a GCP whatever load balancer or the DigitalOcean new some other exciting load balancer. Don't care. I don't care about storage underneath my application. I just want storage to be there. I don't want to care about the cloud provider. I don't want to care about whether it's running in my own data center or on somebody else's. I just want to care that my application is there and that it runs, and that I can interact with it the same way, regardless of where it lives, and be able to make it run. And that's the beauty of Kubernetes, and that's the beauty of this right here, this fantastic node set, which acknowledgements go out to Henrik Schmidt, who works with us, Russell Wu, and Ivan, I'm not even going to try to butcher that, and Stefan Szymanski. These guys all worked very, very hard on coming up with a solid way of doing this and actually implementing it as well. There's a lot of discussion in the Kubernetes community now about how to do this, so you may actually see this implemented pretty soon in some of the other cloud provider specific implementations of Kubernetes. But it's also available open source at kube-node on GitHub, so you can totally check that out. Quick mention, because I have to, we are hiring in Hamburg, Berlin, San Francisco for another month. Well, we still have an office there, and remote. So if you're interested in coming and hacking on Kubernetes, you do some Golang stuff, you're interested in doing some Golang stuff, you're interested in coming and hanging out and learning some more about Kubernetes, come chat with us, because we're more than interested to talk to you and and see what you can bring to the table and see what we can help you move forward with. So, questions? No questions. You are all lost right now. Or in awe. So, I mean, yeah, for those of you who are in awe, pretty freaking cool, right? Like, and one of the advantages that I didn't mention about this that makes it really cool. So how many of you guys are familiar with the HPA, the Horizontal Pod Autoscaler? Okay, so there's this cool, fantastic little piece in Kubernetes. Sorry, I'm getting excited. Okay, so there's this super awesome thing in Kubernetes called the Horizontal Pod Autoscaler. So I used to work for a company that does, for the record, does not use Kubernetes and does not use anything scalable whatsoever. So they ran like 500 and something, we don't actually know the exact number, 500 and something physical nodes, because every time, this was a clothing retailer online, and every time they ran a commercial, they would get like anywhere between 100 times the traffic and 500 times the traffic of what the site was used to doing, which meant that they had to have their nodes, because we created nodes by sending an email to a hosting company and then waiting a day for them to give us the IP address of the node back. So great API there, let me tell you, it was fantastic. Very easy to automate too, as you can tell. So that was exciting in and of itself, but we had to have nodes just sitting around waiting all the time for us to have this high volume traffic, which meant when I ran some rough numbers, we were running somewhere between 0.5% utilization and 2% average utilization of our resources. One of the guys on the Kubernetes team, his name's Matthias, fantastically, famously said, I pay for 100% of my CPU, why shouldn't I use it? And I agree with that. Why shouldn't we be using the resources? Coming from maybe a moral perspective, or maybe a little bit more of a environmental perspective, when you take a look at average utilization across companies, you're looking at 10%. Maybe 15% if they're doing really well. If a company is doing fantastic, typically you're looking at like 30% at most, average utilization of their resources. Which means that even in the best companies, we're looking at like 70% waste. 70% of those servers don't need to exist. We didn't need to invest the energy in building them. We don't need to invest the energy in running them. We don't have to have all of the hazardous materials that are in them sitting around. We don't have to waste all of this space taken up by data centers. We could just like make that go away. Not to mention that like having a bunch of servers sitting around requires a whole bunch of people to just run around and change hard drives all the freaking time. Hard drives break, right? So imagine we could make 70% of that go away. The amount of energy we would save in cooling, the amount of energy we would save in the construction of the servers, the amount of energy we would save in running those servers, that's huge. Huge. But nobody does it because it's hard to do. Kubernetes gives us the advantage to be able to do that, theoretically. So where the Horizontal Pod Autoscaler comes into play, which is fantastic, is when you have a Kubernetes cluster and you have this little piece, it's just a thing that looks at custom metrics or the CPU utilization and memory utilization of a pod. And it goes, oh shit, sorry. I think it's against the rules of the conference to swear, I apologize. Oh goodness, there we go, much better. You can edit that out, right? Oh goodness, you've gone above 70% utilization. You've gone above 80% utilization. I want to add more to the cluster. It'll automatically scale that up for you. And then when there's no traffic on it, it'll automatically scale that down for you and go back to 1 or maybe 0. 0 is usually a bad number, but 1 is usually pretty fantastic. And so when you only have 1,000 users on the site right now, you can handle that with 1 or 2 or 3 pods. And then when you have 500 times the traffic, it goes, oh, I need more, oh, I need more, oh, I need more. It keeps adding pods. Here's the problem with that. you keep adding pods, eventually you run out of resources in the cluster. That's not so awesome when people are trying to get to your website, and now nothing works for anybody because you have no CPU and have no memory left. But now you have this cool thing called a NodeSet that you can do the exact same thing that you're doing with pods autoscaling, you can do with nodes autoscaling, and go, hey, if I have things that are scheduled, but I can't put them on any nodes because I don't have any resources left on the nodes, go ahead and add some nodes. Oh, I've got nodes that are under 50% utilization. Let's go cordon those, move all of the workloads off of it, and then kill the node. Now I don't care how many servers I run, because if I'm over 80% utilization, I'm adding one. And if I'm under 50% utilization, I'm shooting one. And now I'm doing 20% better than even some of the best companies out there that are doing their own stuff. That's a 20% savings in energy. That's a 20% savings in servers. And that's, we can make that 30% just by changing one number and saying, oh, do 60% utilization instead. And it's really simple for us to you want to meet some environmental targets? Change 2 numbers in your cluster. Done. And that's pretty fantastic. That's one of the beauties of Kubernetes that not many people talk about. That makes things really cool. Not only does it make your job as an operator way easy, and make your job as a software developer deploying your application way easy, but it also makes your job as a decent human being caring about our planet way easy. It's a win for everybody, and it's fantastic. So, yay to Kubernetes. All right. Any other questions? Or any questions actually to begin with, because there was none yet. All right, cool. Thanks for coming out, guys.
I'm not quite sure if Jason mentioned it, but if you like to play around with Kubernetes, you can use our free cloud version, cloud.kubernetes.io. Yes, a sales pitch again.
Yeah.
So you can set up for your cluster for free with our Kubernetes product. We support AWS, DigitalOcean, and OpenStack currently. If you're interested in more cloud provider support, talk to us. We also do private installation of Kubernetes at enterprises. So
I'll show you guys how to stand up. This is the easiest way to stand up a Kubernetes cluster on pretty much every cloud provider right now. Here is talking about stuff. There we go. I should have generated a name. That would have been more entertaining. DigitalOcean, because I don't have keys. I just go get new ones all the time. Thank you, Cloudflare.
DDoS protection.
All right. Oh, you can see my nodes. They're awesome. They're named my NodeSet something. API. Give me a token.
He will definitely delete the token after the presentation, so don't copy it.
And if you're laughing about the name, come on, guys. It's the easiest thing to possibly type with your left hand, and I'm left-handed, so. Where are we going to stand this up? Let's put it in Toronto, just because I'm Canadian and I feel like being uber Canadian today. So you can add your own SSH key too if you feel like it. I don't. I already have one there. And really just no, I'm not going to go that far. That would have been mean. That would have been mean. So yeah, we're going to stand up one 32 gig node. Goose is talking about stuff is successfully created. So now we're standing up all the cluster resources. Currently, the master components are living in the US. And then we have this cute little node that's going to stand up in Canada, in Toronto. They're kind of close to the Frenchies, so So we have the API server, the controller, the cluster controller. I really should put the right name in there. The etcd, scheduler, and then the node controller. That's that extra component that I talked about earlier, all running inside our cluster. So you don't pay for running any of your master resources, which makes us different than everybody else. Also, actually HA, because it's running in Kubernetes, and we run at least 3 of all of these things, which is kind of cool. Even GCP, for the record, doesn't do that. They run 1 VM with all of your stuff on it. So if that VM dies, you have to wait for it to get recreated. Thank you, GCP.
And the GCP VMs dies really often.
You would be surprised when you actually start monitoring your API servers on GCP, which is hard to do because they kind of like try to make it abstracted away from you. Not the healthiest thing in the world. So here we go. We have a Kubernetes cluster. I clicked like 3 times and typed some stuff. And now I can just download a kubeconfig and start working with this cluster. Super, super simple. You can see that my node, as soon as the cluster came up, is going to be added. And away we go. So very, very easy to start playing around with Kubernetes for those of you guys who haven't played around with it much. For those of you guys who have played around with it much, you probably see how awesome this is already. And if you want to just like spin up a cluster to test some stuff out, just use Cloud. Like it's super, super easy to just hop on there if you want to play around with spinning up a MySQL cluster or something, or see how Vitess works. Easy way to do it. So, yeah, there we go. Any questions about Kubernetes?
That was a sales pitch, sorry.
All right. Thanks, guys. Go do something.